All right, today we're going to talk about complex numbers. We're going to do an introduction to them, and then we're going to learn how to add complex numbers, okay? All right, so first, what are complex numbers? So first, let's look at the number system, okay? So you have your complex numbers. Let's get a color. So you have your complex number. That's your top tier, okay, right here, complex numbers. And it is in the form a plus bi. All right, so then it splits down to 2. So then you're more used to the left-hand side than the right-hand side. So if b, so see how b is with I? Remember from Math 2, I is your imaginary number? Okay, remember when you took the square root of a negative number, you pulled the negative out with the I. So the square root of -4 is plus or minus 2i. Okay, so if b is 0, and you know when you have 0 times anything, it's just 0, that comes to where we get our real numbers, okay? And then your real numbers split to rational or irrational, okay? So your rational numbers, you either have your negative integers or you have your positive integers, okay? And those are going to be your rational numbers are like your 1.5, your 1, your 2, numbers you can count, okay, that you're more used to. Irrational numbers are those crazy numbers that just go on and on and on and on and on, okay, like the square root of 2, that is irrational. The square root of 5, pi is irrational. We're going to talk, we talked about e in Math 3. Remember e? That's an irrational number, okay? Now, if a is 0, so now if a turns 0, it goes away, and you're just left with the I, which is just your pure imaginary form, which is what you saw in Math 2, okay? All right, so here, complex numbers, that's what we're going to be talking about. Complex number is a combination of a real number and an imaginary number. So you were just used to seeing the imaginary number not put together with the real number, okay? So an example of a complex number would be 3 plus 2i, or 5 plus -15, because the square root of -15 will have that I, okay? So anytime you take the square root of a negative number, you are going into the realm of imaginary numbers, okay? So where does imaginary numbers come from? Like I said, right, if you look down here, if you take the square root of a negative number, you get an imaginary number, okay? Now, I by itself is just the square root of -1, okay? So, complex numbers are written in the form of a plus bi, where a is the real part and b is the imaginary part, okay? So you'll have a whole number, and then you'll have a number with an imaginary number, okay? And just remember that I is the square root of -1, okay? So what happens if one part is 0? So if you look at this column right here, okay? So first you have your complex number where neither one of them are 0, and so your real part is 3, and then your imaginary part is the 2i, okay? Now, if your imaginary number is 0, so this is like saying plus 0i, then your real part is 5 and your imaginary part is 0, okay? So really when you're looking at whole numbers, there's an imaginary part, it's just 0, all right? And then if you just have an imaginary number, that means your real part is 0 and your imaginary part is the -6i, okay? And that's purely imaginary, and the one above would just be purely real. So let's get to the adding of complex numbers, all right? So think back to when you were adding, really when you're combining anything, when you're adding, you always add like terms, okay? So it's kind of like a matching game. If they do not match, you cannot add them together, okay? So you could not add a real number to an imaginary number because they don't match. But you can add an imaginary number to an imaginary number, and you can add a real number to a real number. So what does all that talking mean, okay? So when adding complex numbers, you add the real parts together, and then you add the imaginary parts together, okay? So these are your real part. So the 3 and the 8 is your real part. And then the 7i and the 11i is going to be your imaginary part. So that means I can say the 3 plus the 8, and that's how I get 11. And then I'm going to say 7i plus 11i and get 18i. So remember when you have like, so a little side thought over here, when you had like 2x and 3x, you know you did nothing to the variable, you just added the coefficient, so this was 5x. Same thing here when you're adding, okay? Adding and subtracting have the same rules, but multiplying you're going to have different rules, okay? So when you're adding imaginary numbers, you kind of just leave the I alone, treat it like a variable, and you're just adding those coefficients. So I said 7 plus 11 and I got the 18, and then I just added the I. So this would be your answer, 11 plus 18i, okay? All right, so that is your guided example. So now let's do, let's work on some examples ourselves together, okay? So I've got 3 plus 2i plus 1 plus 7i. All right, so we're adding, so you take the real numbers first. So my real number is 3 and 1. So I'm going to say 3 plus 1 and get 4, okay? And then I'm going to add my imaginary numbers, which is 2i and 7i. So positive 2i plus positive 7i is going to give me positive 9i. And that is your answer. Easy breezy. Okay? All right. Next one. Simplify the following expression. So anytime they tell you to simplify, I should have said something on the first example, but simplify just means another version of what I gave you, just in simplest terms. Like so if I gave you like a fraction, 6 over 8, and I want it in simplest terms, well, you know, you can reduce that to 3 over 4, and that would be the simplest term. They're the same fraction, it's just one's a reduced form of the other form, okay? All right, so here, same process. You take your real numbers first, add them together. So I'm going to say 3 plus 4 and get 7. And then you're going to take your imaginary numbers and add them together. So I'm going to say 5. And now this is a negative. You've got to pay attention to what's in front of that imaginary number. So this is really negative 3. So I'm really saying 5 minus 3, which would be a positive 2i. Okay? All right, let's do another one. So the next one says, simplify the following expression. Now this one, I want you to pay close attention. If you look at this first set over here, there's no real, okay? And that's fine. It doesn't have to have the real. It can just be an imaginary number. So if there's no real on the first one, I have nothing to add to the 3, do I? So I'm just going to bring that 3 down, because there was nothing to combine there. It's like when you were in Math 3 and you were doing, you were simplifying a polynomial, you were combining like terms. If they didn't have if they only had one x squared term, we just brought it down. Same thing here. I only had one real part, so I just brought that 3 down. So then I've got my imaginary part, and it's negative 3i plus 5i. So that's really saying negative 3 plus 5, which is going to give me a positive 2. So it's going to be plus 2i. Okay? All right. So now you can have multiple sets. Okay? But again, you're doing the same thing. You're collecting all your reals, combining them, then you're collecting all your imaginary, and you're combining them, okay? So I have a 5, and then I have a 7. So I'm going to say 5 plus 7, which is going to give me 12. So that real part turns into 12. And then I've got my imaginary, which is positive 6, positive 5, and another positive 6. So that's going to be, let's see, that's 12 plus 5, that's 17. Yes. So that's going to be plus 17i. Don't forget to add that I back in there, okay? All right, so we'll just put that here. All right, so that is it for adding complex numbers, okay? And let me know if you have any questions.